Right now, at this exact moment in history, we're heading into something no space agency like NASA has ever really planned for. The mysterious object we've been watching closely for months, once called 3I Atlas, is speeding toward a key point in its trip through our solar system. This moment in time and space could change everything we know about objects coming from the deep darkness outside our solar neighborhood. What's really worrying is that we're about to lose track of it completely, just when it might do something amazing. Let me break down what's happening, because this goes way beyond just stargazing. It questions what we think is possible in physics and even our role in the universe. When 3I Atlas first showed up on our screens earlier this year, astronomers around the world were thrilled. It was our third confirmed visitor from another star system. A real piece of a distant world dropped right at our door. It gave us a shot to study something from outside our solar family, using tools way better than what we had for the quick visit of the first one, Oumuamua, in 2017. Since we spotted it, we've followed 3I Atlas with amazing accuracy as it blasts through space, picking up speed toward the sun at over 200,000 kilometers per hour. We've carefully noted its strange, slight slowing down at times, like it's lightly braking against the sun's pull, going against normal rules of orbits. We've seen its path line up almost perfectly with our solar system's flat plane, where planets circle, with less than a 1% chance if it was just random. And most importantly, studies point to a weird, possibly hollow inside structure, something that totally breaks what we expect from natural space rocks formed slowly by gravity over ages. So far, things have followed science rules and path predictions, even with growing oddities. But we're just days from October 29th, 2025. That's when 3I Atlas hits perihelion, its closest point to the sun, passing at about 1.36 astronomical units. For reference, that's just inside Mars's orbit, hitting it with the strongest sun heat and gravity it'll face here. This is the big test the science world has been waiting for with growing nerves. Will it act like a comet or something totally different? Regular comets from our system, those icy, dusty clumps, usually react to perihelion heat in expected dramatic ways. They might shatter completely from huge temperature differences that rip apart their weak build, turning into a swarm of bits. Or they grow bright tails stretching millions of miles as buried ice turns straight to gas in the vacuum. We've seen this happen over and over in astronomy history. So, this perihelion is the ultimate natural test we've been gearing up for. We've aimed every tool we have, coordinating watches from different continents and space platforms to catch exactly what goes down in those key hours as us 3I Atlas faces the fire. Will it act like a weak snowball or something tougher? But here's where things get truly creepy. As 3I Atlas hits this peak moment, swinging closest to the sun from October 29th to 31st, it'll also slip right behind the sun from Earth's view. It enters a superior conjunction, a lineup we knew would create a weeks-long blind spot. The sun's position blocks our sight, making even our best scopes pointless against its bright glow. Think about that timing. This odd visitor, already showing strange signs, will face its toughest sun challenge exactly when we can't watch. When the angles finally let us look again at the spot where it should come out the other side, still on its curved path out of our system, we'll see one of three things. It could survive whole, maybe changed, but still there. We might spot signs it broke into scattered pieces, finally acting like a big comet should. Or we could find nothing. Tons of observatories are set for the hunt back. The James Webb Space Telescope has time booked. Ground radars will sweep carefully. The whole astronomy world is holding its breath, excited but nervous, to see what, if anything, pops out from the sun's glare. Once the blind spot ends, advanced systems from groups like the European Space Agency will scan the exact path zone. That's where about 33 billion tons of stuff should be moving at predicted speeds, following gravity rules. But the big question in every control room, the one few say out loud, is, what if it's gone? What if 3I Atlas just disappears? Before jumping to wild sci-fi ideas, let's stick to solid science and check normal explanations first. Could it break apart so totally at perihelion that the bits are too tiny and spread out for our gear to pick up in space's clutter? For big comets hitting strong heat for the first time, yeah, that's possible, maybe even probable. Sun warmth creates massive stress. One side roasts while the other stays frozen. Swings of hundreds of degrees can rip loose, icy bodies to shreds. We've seen it with our own comets plenty of times. But here's why scientists worldwide hesitate to just blame breakup for a total vanish. When comets explode, they always leave clues. We see growing clouds of gas and dust spreading over millions of kilometers. Dust streams catch sunlight and linger for weeks or months along the path. Even small chunks follow slightly different routes we can track with good tools. Hubble, for example, can spot things smaller than a city block from far away. Yet right now, thorough searches of the predicted exit zone, done by many independent teams with various methods, show nothing solid, no growing debris cloud from a huge split, no dust signs we'd expect, and no confirmed pieces on the after-perihelion paths. The lack of data is as loud as the quiet from space agencies. The other normal idea is mistakes in our path math. Maybe our detailed predictions missed something subtle, and it survived but came out on a way different route, outside our search areas. But this runs into huge math hurdles. We tracked and 3i Atlas non-stop for months before perihelion, nailing its spot, speed, and tiny speed changes with top accuracy from sites worldwide. Calculations included Einstein's relativity tweaks near the sun, sunlight pressure on its coma, and pulls from every big planet. Error ranges are tiny, just hundreds of kilometers over hundreds of millions. To totally miss it on reappearance would need path shifts way bigger than any natural thing like gas bursts or light push could cause randomly. We're not talking small wiggles in normal error zones. It'd be like a mountain-sized thing suddenly making a sharp turn mid-flight, maybe toward Jupiter's path instead of the expected curve out to the cold edges, as if breaking every orbit law we know. That kind of sudden major path change would need huge forces we just don't see on natural space objects, forces that start to hint at scary ideas about what we're really looking at. This big shift doesn't happen from normal natural causes. That leads us straight to the third possibility. It's the one Harvard astrophysicist Avi Loeb has been urgently warning about since his team studied 3i Atlas's slowing patterns months ago. What if the disappearance we're about to see, this possible vanishing behind the sun, isn't an accident? What if perihelion, especially around October 29th, is exactly what some scientists quietly feared? A perfect planned chance for a big path change, hidden completely from all Earth and space watchers by the sun's bright glare? Let me quickly explain the physics of what could happen in those hidden hours or days. The Oberth effect, named after German rocket pioneer Hermann Oberth, describes a tricky rule in space motion that goes against our daily gut feelings about speed and energy. In simple terms, if you fire an engine at the deepest point in a gravity pull right when you're moving fastest, even a small push creates massive changes in your final path and energy. The deeper in the gravity and the faster you go when you thrust, the better it works. It's the best time to make big turns while using the least fuel. Perihelion, 3i Atlas's closest sun approach on October 29th at exactly 11:47 UTC, is the deepest spot in the strongest gravity well for billions of kilometers around. It's the bottom of the solar system's gravity pit. If 3i Atlas has any hidden engine inside that strange, possibly hollow structure Loeb's math suggests, if it has enough stored power for even a small controlled push, then that exact perihelion moment is the perfect time in its millions of years trip to use it for huge results. Imagine what even a tiny speed tweak could do, a delta V of just a few hundred meters per second, timed perfectly at perihelion. That's a small slice of its total speed, possible with advanced tech we can only guess at. It could turn its open, escaping curve into a closed-loop orbit. What looked like a short visit becomes a forever stay, trapped in our solar system. Or that same well-timed push could steer it to key spots inside our system. Maybe the asteroid belt for secret meetups or resource grabs. Or toward the outer gas giants for long-term quiet watching of our worlds, safe from Earth eyes for centuries. The timing is either wildly suspicious or another crazy coincidence piled on a growing list of weird stats. Our watching ability goes totally blind for key weeks. Exactly when any big engine burn would work best and stay hidden behind the sun's 1.4 million kilometers of blazing plasma, blocking every wavelength. When the angles finally let us look again in December, we'll learn if the object just vanished, like it used our blind spot for a clean escape or a total plan switch. Now think about what we already know from 3i Atlas's actions before the blind spot. The pattern looks more like careful planning than random space drifting ruled only by gravity. It arrived lined up with our solar system's flat planet plane to within 5 degrees, something that happens in less than 2% of truly random interstellar entries. It slowed down on purpose between September 23rd and 26th, dropping from 68.2 kilometers s to 67.9 kilometers s, in ways that break every known natural rule for lifeless rocks falling toward a star. Its density, from brightness and gravity clues, points to a hollow inside. That makes no sense for natural buildup over time, but perfect sense for built objects needing low weight and safe space for gear or cargo. It also survived a direct hit from a solar storm in September, a massive blast of charged particles that should have ripped any loose ice dust clump to bits. It kept super steady spinning through months of watching, way more precise than natural, randomly formed tumblers ever manage. And most eye-opening, it flew by Mars on October 3rd at exactly 29 million kilometers, with odds of random timing under 1 in 50,000 when you count the full path from deep space. Taken one by one, each oddity could maybe be explained with rare natural causes, weird chemicals for toughness, lucky angles for the Mars pass, some new ice melt process for the slowdown. But put them all together, they form a clear, strong pattern. Patterns in nature usually mean some organizing force. Whether known physics or maybe smart design, we're just starting to consider. What we're seeing with this possible disappearance is totally different from Oumuamua in 2017. Yes, that first visitor acted strange, speeding up without visible gas, super long shape hinting at artificial make. But it followed a predictable escape curve. It came, acted odd but trackable, and left on a path we could follow until it faded. 3i. Atlas might do something else entirely. If it follows its past hints and uses the Oberth boost, it won't just drift away. It could vanish fast from its expected route, forcing us to question basic ideas we've held for ages. The official responses are worth watching too. NASA stays neutral, stressing more study needed. ESA admits the blind spot, but leans toward breakup as the reason for no detection. China has gone quiet since the Mars flyby. This info clamped down during weird interstellar visits has happened before. Sure, it could be paperwork or tech delays, but the pattern across events and countries hints at planned caution, maybe from uncertainty or worry about big missteps. Not a conspiracy, but smart handling of data that could flip science upside down. If proof is wild, any announcement will need careful wording and global teamwork. The next weeks are make or break. Observatories everywhere are hunting hard. Webb has booked slots. Radar systems scan the skies. If all this turns up nothing, if 3i Atlas truly vanishes with no trace or solid natural reason, we'll have to face ideas once stuck in sci-fi. Could it hide on purpose? Did it pull moves so big they're way outside our search zones? Or was this disappearance a planned exit right in our blind spot? Natural or artificial, broken or flown away on purpose? 3i. Atlas has already done something huge. It's pushed our science view past safe beliefs. It's shown the universe doesn't have to fit our ideas. And it's reminded us that watching closely is our best weapon, especially when what we see shakes everything we thought was true.